have a look at question 4. Question 4. Question 4 says the induced current, the induced EMF versus time graph of an AC generator is shown below. Right. Sketch the graph to show how the above form changes, if at all, after changing the generator to a DC generator. Right. The important thing here, ladies and gentlemen, is the minute we change it to a DC generator, my graph, I will still have, I'm just going to draw it here so you can see, I will still have my E and my induced current, which is volts. I will still have my time, and all that will happen now is my graph would look like that. Right, you got that. So my graph would just look like that. Okay. Yeah. Right, next question now. You see, I've just told you, state 2 advantages of AC over DC for long distance transmission of electrical power. Can you see? It's exactly the same as the same question we had in 3.1. Right, so the first thing you're going to say is, I would say that it's easier to generate and transmit AC current, right, and less energy is lost in the transmission of AC current. You could have also gone into that about the voltage and all things like that. Right. And here they've asked you the 2 advantages of AC over DC. Right. Okay. Now let's carry on with question 5. Right. Question 5. The average power of a lamp is 15 watts. The lamp can be used either as an AC supply or a DC supply, and the graph is shown below. Now they say to me, right, the first thing you had to do here, people, was to identify that this was AC, right? And from that, there is some information that we already have. They say to us, calculate the potential difference of a DC supply that will produce the same brightness of a lamp. Right. Okay. So, what you would have to do here, DC supply would mean you'd have to work out the RMS. Okay. The question they want you here, what you actually have to work out is you have to work out VRMS. Because remember, a DC supply is in a straight line. Okay. Right. And what will happen is your straight line will be at the RMS, at the root mean square. Right? So you would have to go and, so your DC supply would actually look like that. Right. Okay. So what would happen over here now is you'd have to go and work out VRMS. And remember, VRMS is going to be equal to Vmax over the square root of 2. Vmax is 12 over the square root of 2. Right. Let's quickly have a look again. 12 divided by square root 2 equals 8,49. So that would be equal to VRMS would be equal to 8,49 volts. Right, okay. So in other words, you would need a DC supply that can supply voltage to you of 8.49 volts. Right, the next question, and that would then give you the same power. Calculate the peak current through the lamp when it is connected to a 12-volt AC supply. Right. Now, once again, there are quite a few things that we could do here, so let's just quickly go and see what information we've got. Right, there's my data sheet. Right. We have got, we know that V max is equal to 12 volts. We've just calculated that VRMS is equal to 8,49 volts, right? And they want to know, and we also know that the power is equal to 15 watts, because that is what they've asked us, right? And they want us to calculate Imax, right? Okay. Now, immediately when I look at this, the only way I can get Imax is to have IRMS. So the first thing I am going to have to do is calculate IRMS. Right, so let's go back. We eventually want that, but first we must get IRMS. Right, now we've got power, we've got VRMS, and we've got IRMS. No, we want IRMS. So we can once again, we can use power, average power is equal to VRMS times by IRMS. Remember, RMS stands for root mean square. Power is 15 is my average, is equal to 8,49 times by IRMS. And once again, can you see I'm putting my little subscripts in? So my IRMS is going to be equal to 15 divided by 8.49 equals. Right. So I'm going to put it here, then you can see. So my IRMS is going to be equal to 1,77 amperes. Can you see, Matrix, that we haven't answered the question yet? We haven't answered the question yet. So we now need to go and calculate Imax, because that is the question, right? I go back to my data sheet and I see the following formula. I see that IRMS is equal to Imax over the square root of 2. So I write down my formula. IRMS is 1,77 volts, which is equal to Imax over the square root of 2. Therefore, Imax will be equal to 1.77 times by square root 2, which is going to equal to 2,5 amperes. There's my answer. You got that? Right. Now, in the next question, they ask me, draw a sketch graph of current through the lamp against time when connected to an AC supply. Indicate the values of peak current on the graph. Right. So remember, this was a voltage time graph. Now they want us to draw a current time graph. So it's going to be current versus time in seconds, current in amperes, and you need to just get your graph. So that's going to be 2,5, and this is going to be negative 2,5. Right, and that is going to be your graph.